This is the Chapter 6 review to get you ready for the test that you're going to have on quadrilaterals. So I'm going to go through and explain all the problems. On the first ones, the first three, these are the sum of the interior angles and finding one of the angles and things like that. We didn't get a chance to do it this year because of the online learning, but there is a formula anytime that you want to know the sum of the interior angles of any polygon. So like this hexagon means it has 6 sides. The formula is just going to be the number of sides minus 2 multiplied times 180. Since it's a 6, you're going to go 6 minus 2 times 180, which is 4 times 180. That means that the total of the interior angles of a hexagon, if you added every single one of those angles together, it would be 720 degrees. On the second one, it says how much does each interior angle, and because it's talking about every single one instead of all of them put together, you're still going to start with that same formula where you go n minus 2 times 180, but then afterwards you only want one of the angles, so you're going to divide by however many angles you have in there. So you divide by n. In this case, we're talking about a pentagon that has 5 sides, so you'd go 5 minus 2 times 180, and then you're going to divide that number by 5. So it's going to be 3 times 180, and then divide that by 5. So 3 times 180 is 540. Once you divide by 5, you find out every angle is 108 degrees. So that's how they work, in case you were wondering. The third one says the sum of the exterior angles of a hexagon. The nice thing is the sum of the exterior angles doesn't matter what the polygon is. If it has 3 sides and it's a triangle, 5 sides, it's a pentagon. It doesn't matter how many sides on the exterior, it's always 360 degrees. There's no work to do there. If you wanted one exterior angle, so if you wanted one exterior angle, you would get 360, the total, and then you would divide it by however many sides it has. So on this one, you would go 360 divided by 6, because a hexagon has 6 sides again. So one angle would be 60, and all of the angles put together is 360. Number 4, this is a parallelogram, and that means the consecutive angles are supplementary. I'm going to put sup for supplementary. That means that they add up and they equal 180. So you get 5x, add it to the 10x. Together that makes 180 degrees. Combining like terms, 5x and 10x is going to be 15x to equal that 180. And then at the end you divide by 15. That's how you can find that x is 12. Number 5, we're still on a parallelogram, but this time they're across from each other. That means that they're congruent, or they're equal. So you make an equation out of that. You go 5x equals 2x plus 33. Moving this across the equal sign, you're going to subtract. So you'd have 3x equals 33. Then you have to divide both sides by 3 to find x is 11. Number 6, this one's asking you for AB. So if you look where AB is at, it's this side right here, this diagonal. It's 14 up here. It's bisected. That means it's 14 down here. So if you get the 14s and add them together, you're at 28. If I wanted to know DC, it would have been 15 and 15, and it would have been 30. Number 7 is asking for AB. So we're looking at this side right here, this diagonal. This time it tells you it's a rectangle. So it's 9. This side's 9 for that segment. Over here's 9. Over here's 9. So from A to B, since that's what we're looking for, add those two together and you get 18. Number 8, it says label all the equal segments. So if you do it with symbols, your life is a lot easier. If you list them, it's going to take you a lot longer. So if you're just marking them on here, since you do have a drawing, You could say that the left side is congruent to the right side just with that mark. You can say the top is congruent to the bottom by putting that mark. You could say that this half of the diagonal is congruent to the other half. And then on the other diagonal, they're actually exactly the same. So I'm going to use the same 3 marks right there. That's it. If you're listing them, you're going to have a long list, but you can do that. As long as you know that the top is congruent to the bottom, left is congruent to the right side, and from the center of this rectangle out to the angles, to the vertices and the corners, those are always going to be congruent to each other in every single direction. That means that this diagonal is congruent to this diagonal. Number 9, because it's a rhombus, this is a right angle. These are perpendicular diagonals. And since we have that, we can focus in on this triangle that's created from the diagonals and the sides. And it goes back to the SOHCAHTOA trigonometry chapter. So if we're looking here, x is your opposite from 42. 50 is across from the right angle, so it's your hypotenuse. Opposite and hypotenuse is sine of the angle. And then for the fraction, SOHCAHTOA tells us opposite goes to the top, hypotenuse goes down to the bottom. Remember, when it's down here, that means you're multiplying. So you're going to write 50 times the sine of 42. You're going to put that in your calculator. Make sure you're in degrees. And that's going to give you 33.5. If you put it in the calculator correctly, in degrees. Number 10, the quadrilateral that's also a parallelogram and a rhombus and a rectangle and has all the rules, the most beautiful of all quadrilaterals, is a square. Then we get to the backside. Number 11 is kind of sneaky because it tells you it's a parallelogram. Watch out. Same thing over here with number 12. It says it's a parallelogram, even though it looks like a rectangle. But on the parallelogram, the opposite sides are congruent. So that means you can get this 5x minus 5, and you can make it equal to the 40 that's on top of it. If you add 5 to both sides, you find 5x equals 45, and then you divide by 5, and you find x is 9. As far as the y goes, on the parallelogram, diagonals bisect each other. This is the same on both sides of that intersection. So that means you can make 3y, I'll put it up here, 3y equal to 15. Just divide by 3 to do the opposite and be fair. And that's how you can find y. Number 12, be careful. It looks like you should be able to make them equal to 90 because it looks like a rectangle, but this really specifies it's a parallelogram. On top of that, this 130 is definitely not a right angle. So for the y side of things, remember that when they're across like that, you can make them equal to 90. 5y. Sorry, you can make them equal to each other. 5y equals 130. Divide by 5 on both sides. And you get 26. For the x, remember that consecutive angles, the ones next to each other on a parallelogram, are supplementary, meaning that they add up. So you have to add that 130 to it, and together they make 180 degrees. Now you have to combine like terms right here. So you get 2x plus 133 equals 180. Then you have to subtract 133 to get it across that equal sign. It's getting kind of crowded in there. But you get 2x equals 47. So last step, divide by 2 to get the x all by itself. 23.5. Number 13, this one is a rectangle because you have these 4 angles. And on top of that, you have all 4 sides, making this a square. Because it's a square, that means every single side is equal to each other. So since it has 14 down here, 2x plus 4 equals 14. Subtract 4 from both sides. 2x equals 10. divide by 2 on both sides, you get 5. 3y minus 1 also equals 14. So if you add 1 to both sides, you get 3y equals 15. Divide by 3, and you get y is also 5. Don't try to make a pattern out of that. It just happens to come out to be the same thing on this example. Number 14, this is not a square, but it is a rhombus because all 4 sides are congruent. That means that we can make all the sides equal to each other. So like right here, we have 5y minus 2 and 2y plus 10. We can make those equal to each other. 5y minus 2 equals 2y plus 10. Then we can solve it by doing the opposite and being fair to move things across the equal sign. Do the opposite, be fair. And then we want to get the y all by itself, so we divide both sides by 3. And we find out y is 4. For the x side of things, you got to watch out. This is not a square. You can use the rule for the parallelogram, but not the one for the square. That's not equal to 90. These two are supplementary because they're right next to each other. So 2x minus 5 plus the 120 together make 180. Then you're going to combine these two together. You're going to get 2x plus 115. You have to subtract 115 from both sides. That gives you 2x equals 65. Last step, divide by 2 to get it all by itself. And then x becomes 32.5. Number 15, it says up here that it's a square. That means all 4 sides are the same. It also means that the diagonals are perpendicular and they're congruent. And because of that, this part of this diagonal is 10. So if we go back to focusing on just a triangle, like we did on that problem in the front, this right here is a right triangle. We don't need to use the trigonometry. We have Pythagorean theorem. So since it goes a squared plus b squared equals c squared, and the 2 legs would be your a and your b, that's 10 squared plus 10 squared equals, and then the hypotenuse goes right there, x squared. Then you go 10 squared is 100, 10 squared is another 100. Add those together, that's 200. But at the end, you have to square root it because you want x to be all by itself. Once you square root 200, you get 14.1. So that's x over here. That's also going to be what a is. So you can recycle that work. You don't have to do it all over again. Y, remember this is perpendicular. Y is 90. When it comes to b, if this is 90 here, and this is 2 angles that share the leftover 90 degrees, it's got to be 45 for angle B right there. Same thing's going to happen in this triangle on the top. These two are the same. It's isosceles. If that's already 90, then 180 minus 90 leaves you with 90 degrees. If that 90 is being shared half and half, C also has to be 45. For number 16, tells you it's a rhombus. Remember, rhombus has perpendicular bisectors. That means C is easy. It's 90 degrees because it's right there where those diagonals are intersecting. To find B, if you look at the triangle down here, you can go 180 minus the 90 from the right angle and the 52 that was given over here. And you'll find out that it's 38 degrees. That's how we find B. And then something nice happens with the rhombus. If you twist it like this, it's probably a little bit easier to see. If this is split right down the middle, if that's 52, then X is also 52. And then remember, if you think about it like a reflection, if X was 52 over here, Y is also 52. And then as far as A goes, because it's a rhombus and all four sides are congruent, this 4A plus 7 can equal to that 27. Then if you subtract 7 from both sides, you get 4A equals 20, and then you find A is 5. Number 17, this is an isosceles trapezoid. It's a trapezoid because the top and the bottom are parallel, so those are the bases that are parallel. And then the legs both have the same mark, so W instantly 14. And since it's isosceles, the base angles are congruent, X is instantly 75. To find Y, since it's on the same leg as the 75, they're supplementary. They add up and they equal 180. Subtract 75. You get 105. And now that you know this angle is 105, Z also has to be 105. You can recycle that work as well. Number 18 is the rectangle. On the rectangle, the opposite sides are congruent to each other. So this 3x plus 1 has to equal that 18. Subtract 1 from both sides. 3x equals 17. Divide by 3 on both sides. And you find out that your x is 5.6666666666. It keeps going. So we're going to round that up to 5.7. For A over here, remember on the rectangle, the diagonals are split into 4 congruent parts. That means we've got that isosceles triangle thing happening right here. And that triangle at the bottom in the middle. So if the left angle is 53, then on that base, angle A is going to be exactly the same thing. And you can reflect that up here. And you can reflect the 53 from A up here. So we can use that later on. For B, since we already know this is 53 and we know A is also 53, for B we're going to go 180 for the triangle minus the 53 from here and the 53 from A. And that's how we can find that B is 74. For C, it's right here. These two angles add up to 90 degrees. So 90 minus 53 will leave you with what C is, which is 37. And now that we know this is 37 over here, we can mirror that across. D also has to be 37. And since we know this one, we can mirror that across. E is also 37. And that's the review.